Dear students, today's lecture topic is on skin effect and skin depth. The last class we studied about the propagation constant gamma. It is a complex function of alpha and beta, where alpha is a real part of gamma and the beta is the imaginary part of gamma. Alpha is attenuation constant and beta is phase shift constant. Just imagine that this is a source point of electromagnetic wave, and this is a receiving point of an electromagnetic wave. And from the receiving point, if you look at the source point, electromagnetic wave is propagating like this. If it is propagating through any conducting medium, it is constantly being subjected to changing its amplitude and phase shift, as the medium will offer some amount of the opposition or resistance to the propagation of electromagnetic waves. So we can see that it's the envelope of this wave function is exponentially changing, which can be represented as e power minus alpha x, where alpha represents the attenuation constant, and similarly its phase is also shifting. At the initial point, if you check the distance of the adjacent crust and raft, that distance won't be when it is reaches close to the destination. So there is a change you can experience from the initial point and the final point. This is also because of when it is propagating through the medium, it is experiencing some amount of changes. And now we are looking into what is a skin depth and skin effect, and let's see that. And also I want to add another point, that if the electromagnetic wave is propagating through as a lossless medium, the value of alpha equal to 0, because lossless medium, there is no electromagnetic energy loss in that medium. But if it propagates through a conducting medium, definitely it will experience some amount of the resistance. So there alpha is not 0, there alpha is not equal to 0. This is the case when it is the electromagnetic wave propagate through lossless medium. So this is the case when it is passed through a conducting medium. Now let us see what is the depth of penetration. Depth of penetration, it is represented using the symbol delta, is defined as the depth in which the wave has been attenuated to 1 by E, or approximately 37% of its original value. It is known as skin depth. Let us see that this is being subjected to some deformation in its amplitude and phase. Now let us take it as initial amplitude is A, and let us take a one point. This point is delta, where the amplitude is 0.37 times A. That means 37% of its initial value. This dotted line represent the exponential the function. That means the amplitude is constantly being changing, decreasing, exponentially decreasing, and it is represented using e power minus alpha x. X is the distance traveled by the electromagnetic wave. Now let us equate these two. That is e power minus alpha x, skin depth is nothing but which is 1 by e. So if you take e power minus 1, which is also 3.37 something, so that's why it is 37%, 1 by e. And at what point it reach, that point is called delta. This is the distance at which the amplitude of wave is decreased to 0.37 times of the initial value. So we can replace this x with lambda. So this become e power minus lambda alpha. So this is equal to e power minus 1. So both are base e, so we can equate e power minus alpha lambda equal to minus 1. So lambda is 1 by alpha. So skin depth is inversely proportional to the constant alpha. Now the same skin depth also we can denote in a conducting medium when a current of high frequency is passing through a conducting medium. Here you can see that this is a conductor, its radius is r, but high frequency current always try to flow through its periphery of the conductor, because on the inner side the inductance is very large, so the high frequency current experience a very high resistance, reactance, so they will try to move to the outer area where it experience a lesser reactance, and this depth is, that means from the surface of the conductor to the area where the concentration of the current is very small, that is being represented using depth. This is also a skin depth of a conductor. And now let us connect, because earlier we studied about the expression of alpha equal to which is omega times the square root of mu epsilon by 2 times square root of 1 minus 1 plus sigma square omega square epsilon square minus 1, and here these two get cancelled, and if you take this term, this become sigma by omega epsilon. So alpha become, if I take this omega inside, this become omega square mu epsilon by 2 sigma by omega epsilon. Now this here omega get cancelled, epsilon get cancelled, this become sigma mu omega by 2. Now what is delta? The skin depth is 1 by alpha, so delta become, it's the reverse of alpha, so 2 by sigma mu omega. This is skin depth. Mu is the permeability, and sigma is the conductivity of the medium, and omega is the frequency of the wave propagation.